Hello students. From last class onwards we are discussing matter around us. Okay. So in previous two classes we discussed about the properties of matter, right? So what are the properties of solids, liquid and gases, and about the internal structure of atoms also we already discussed in yesterday's class. Okay. So in this class we'll discuss about can matter changes of state of matter. Okay, so how the changes will happen. So in the starting itself we discussed, can matter change its state? Yes, right. Okay, so matter changes its state. We already discussed about water, right? It exists in three states. Okay, on cooling, water changes into ice, right? Okay, if you heat the water at some point, at some temperature, it changes into stream. Again, this is a, we can get back the stream into again water. Okay, so this is a reversible reaction. Okay, so let us observe the changes of a change of state of matter detailedly. Okay, so change of state of matter. So in water example we can conclude that, we can say that matter changes from one state to other state, right? Yes or no? So water is in liquid state, it is converting into solid state, that is ice. Again, this water is in liquid state, it's again converted into steam, that is gas state. Okay, so we can change the physical state of matter in two ways. Okay, so we can change the physical state of matter in two ways. Okay, so first one is by changing the temperature. Okay, by changing the temperature, like heating or cooling. Okay, so by changing the temperature of a substance we can change the state of matter. Okay, so second one is by changing the pressure. Okay, like increasing or decreasing pressure. Okay, so we can change the state of matter in two ways, by changing the temperature or by changing the pressure. Okay, so effect of changes of temperature. Let us discuss the effect of change of so if we change the temperature, what are the effects we can notice? Okay, try to discuss that. Solid to liquid change. Okay, solid to liquid change. So it is also called as melting. Okay, so the process in which a solid substance changes into a liquid on heating is called melting or fusion. Okay, so the process in which A solid substance changes into a liquid on heating is called melting or fusion. Okay, so melting or fusion. Okay, so by heating we can change a solid into liquid, right? This process is called melting or fusion. Okay, so the temperature at which a solid substance melts and changes into a liquid is called as melting point of a substance. Okay, so the temperature at which solid melts and changes into a liquid is called melting point. Okay, so the temperature at which the solid melts and changes into liquid is called melting point. Okay, so try to place a ice cubes. Okay, ice cubes on this vessel and place a thermometer. Okay, place a thermometer and start heating. Okay, so what happens, up to a certain temperature these ice will not melt, but after at 0 degrees these ice starts melting. Okay, so the 0 degrees is called as a melting point of a water. Okay, so melting point of water is ice, sorry, the melting point of ice is 0 degree centigrade. Okay, melting point of ice 0 degree centigrade. Okay, different solids have different melting points. Okay, the higher the melting point of a solid, greater will be the force of attraction between its particles. Okay, if the melting point of a suppose substance is very high, then the greater will be the force of attraction between the particles of that substance. Okay, when a solid substance is heated and the heat energy makes it particles vibrate more vigorously. Okay, at the melting point, so what happens, the particle gets sufficient kinetic energy to overcome the strong forces of attraction holding them in a fixed position. Okay, and the break these forces break into form a small groups of particle and solid melts to form a liquid. Okay, so what happens at a melting point, what happens, these particles of this substance start a movement. Okay, so at melting point what happens, on heating this starts moving. Okay, at melting point what happens, these particles in a atom or substance get sufficient energy to overcome these forces of attraction between them and breaks into small pieces and form a liquid. Okay, so next it changes liquid to gas change. Okay, gas change. So what is this called? Boiling. Okay, or vaporization. Okay, so the process in which a liquid substance changes into gas rapidly on heating is called boiling. Okay, so the process in which A liquid substance changes into a gas on heating is called boiling or vaporization. Okay, so here also different substances have different boiling points. Okay, so mm these boiling point is a measure of the force of attraction between its particles. Okay, so what is this boiling point? This is a measure of a force of attraction between these particles. Okay, so when a liquid substance is heated, the heat energy makes the particles again vibrate here very fast. Okay, at the boiling point, what happens? The particles get a sufficient kinetic energy and to overcome the strong forces of attraction holding them in a fixed position, and they break into small particles, and the liquid is converted into again gas. Okay, so uh, the temperature at which, so here again boiling point, the temperature at which liquid changes into gas is called boiling point. So what is the boiling point of water? Boiling point of water is 100 degree centigrade. Okay, 100 degree centigrade. Okay, so here the same. So what is boiling? The process in which like liquid substance changes into gas on a heating is called boiling. Okay, so the temperature at which this boiling takes place is called a boiling point. Okay, so boiling point of water is 100 degrees centigrades. And again here also what happens at boiling point? These particles of the substance get sufficient energy to overcome the forces of attraction between the particles of this liquid substance and breaks into small particles to form a gas. Okay, so next, gases to liquid. Liquid change, again the process is reversing. So what is this process is called? Condensation. The process of change of gas or vapor to a liquid by cooling is called condensation. Okay, the process of change of gas or vapor to liquid to a liquid by cooling is called condensation. Okay, so when the gas is cooled enough, then its particles lose so much kinetic energy that they slow down, move closer together until they start being attracted to each other and form a liquid. Okay, so what happens here? When a gas is cooled enough, then its particles lose kinetic energy. Okay, so that they slow down and move closer to each other, and they attract each other and form a liquid. Okay, so this is condensation. So next is liquid to solid. solid change. Okay, so what is this called? Freezing. Okay, you already studied all these in a previous class, that is in 8th class. The process of change of a liquid into solid by cooling is called freezing. Okay, so the process changing the process of changing a liquid into a solid by cooling is called freezing. Okay, example, when water is cooled it gets converted into a solid called ice. Freezing is nothing but what? Solidification. Okay, freezing means solidification. Okay, so it's becoming a solid again. Okay, so next one more change is there again. What is that? Sublimation. Okay, so what is sublimation? The process of changing a solid directly into gas without going into a liquid state is called sublimation. Okay, the process of changing a solid directly into gas without going into liquid state is called sublimation. Okay, so what are the examples for sublimation? Camphor is a solid, but if you leave in a open air, open air for some time, it directly changes into gas. Okay, so what are the examples here? Camphor. So if you leave in an open place for some time, what happens? This camphor directly changes into gas without changing into liquid. Okay, you may have seen moth or naphthalene balls, right, being placed in your almaras in the middle of your dresses. The smell for some time, even the smell remains for some time, even the balls disappears. This is because the mothballs have changed from solid to gas state. Okay, camphor or naphthalene. Naphthalene. Okay, so try to think a few more examples of a sublimation. Okay, what is sublimation? The process of change of a solid directly into gas without going into liquid state is called sublimation. Camphor and naphthalene, these two are example I'm expressing. Try to note a few more examples. Okay, try to observe. So you can see coconut oil also, generally it is in liquid state, but on cooling it becomes a solid. Okay, mostly you observe the solid state of coconut oil in winter. Okay, so water example already you know very well. Okay, so all the matter is, so matter is made up of very small, even very small particles, you know, right? Okay, all the matter is made up of very tiny particles. Okay, so take a beaker with the water and add so what matter is made up of? Matter is, so try to observe a example or we discuss one activity. So take a beaker with water. Okay, So try to take a beaker with the water. So try to add 1 or 2 crystals of potassium permanganate and dissolve them in a water. So if you dissolve them in water, what happens? These water gets a color. Okay, so I'm adding potassium permanganate, so this water becomes a colored. Okay, so what happens? These potassium crystals have or crystals are made up of very small particles or very small atoms. Okay, so what happens? These atoms are dissolved in water and evenly. Okay, dissolved in water evenly, and we can observe the color. Okay, so take a 10 ml of these colored water and again add in a one more beaker of water of a same amount. Okay, so what happens? This 10 ml of water, again colored water, again it's mixes in this, and again you can see the color intensity will decrease here. Okay, so but intensity is decreasing from this container to this container, but you can see even distribution of the color. Again take a 10 ml of these and again mix with the one more beaker water. So again you can see intensity is decreasing, but you can see uniform distribution of a color. Why this happening? Because the small particles. Okay, so these potassium permanganate crystals are made up of very tiny or very small particles or atoms, right? These atoms are distributing evenly in the water. So we already discussed atomic structure, means how the arrangement of atoms in a liquid, right? You can there is intermolecular space exist compare with the solids. Okay, so what happens? These solid particles uh, occupying the space which already present in a liquid. Okay, in liquid atoms are arranged loosely, right? Loosely packed, right? Compare with solids. On that gaps, these solid is dissolved in water occupy this empty space which is present in a this liquid, and it are distributed evenly in a all. But compare with the first and last beaker or last container, you can see intensity of color will be very less, but it is uniformly distributed. Okay, so we can conclude that there must be several tiny particles in just one crystal of a potassium permanganate which are uniformly distributed in water to change its color. Okay, so both the solids and liquids are made up of very tiny particles, even water also. Okay, so from this we can conclude that both solids and liquids are made up of very tiny particles. Okay, even water also. Okay, so this is a activity to show the distribution of very small particles in a water or liquid. Okay, so next, so how we can say that intermolecular space is present. Okay, space is present in a liquid or gas substances or particles. Okay, for this also let me explain one activity. Take a beaker and pour some water in this and try to add a salt. Okay, so try to add a salt. So what happens? Salt is a solid, right? So in previous activity I said, right, this salt is solid which already here in a liquid intermolecular space is present. We discussed at the time of uh, arrangement of atoms, right, in a different materials. So what happens? This solid dissolves in water and occupies the space present in this water. Okay, so it occupies this space present in this water. So in a what about gas? This is about liquids. So if you take gases, we already discussed one example while discussing the property of a diffusion. Okay, so while diffusion is taking place, what happens, if you if you spray a fragrant at one corner of the room, what happens, these vapors, okay, present in a uh, present in a center, they mixes or they occupies the space already there in a gas. Okay, in a gas, what happens, these atoms are loosely packed, or intermolecular space is more in these gases. These space present in these gases occupied by the scent. Okay, and even the scent or the fragrance moves very fast because intermolecular space is very high compared to the solids and liquids. Okay, so like this, we can say that space is present in a between the atoms of solids and, I mean, sorry, liquids and gases. Okay, so clear till now? So we discussed the properties of solid, liquid and gases, and we already looked into the uh, applications of these solid, liquid, gases properties. Okay, like compressibility. We use compressibility in CNG and LPG gases. In case of CNG and LPG gases, we can compress large amount of gas, that is CNG or LPG, for a portable purpose in a small containers or small cylinders. Okay, so next, diffusion. Diffusion is very very important in our daily lives. You know, already know the oxygen and carbon dioxide diffuses into blood, how we already discussed in yesterday's class. Even for aquatic animals also, diffusion is very very important. That intake, even the water animals or aquatic animals also intake oxygen and releases carbon dioxide. Okay, so at that time what happens, this oxygen is dissolved in a water. Okay, and carbon dioxide also, they take the dissolved oxygen from the water and they release the carbon dioxide in the water. Okay, so even plants also do the same thing. So this diffusion is very important for all the living organisms, even including human beings. Okay, so this is the end of your lesson. So try to collect the examples, more examples for sublimation, and try to observe the another materials or another substances which undergo three states of changes. Okay, like mm, try to observe the, here we already discussed ice on heating or melting or fusion, what happens, it becomes a liquid. Okay, on boiling it becomes a gas. If you condense, or if you condense this, it becomes again a liquid. Okay, condensation. Okay, and this liquid again freezing, you will get a ice. So this is a reversible process. Okay, so name any substance like water undergoes three states of changes. Okay, so thank you.